Good evening children. Today we are going to learn second chapter polynomials and factorization. First we have to recall previous knowledge about expressions. Expressions means what? Combination of variables and constant. What are variables? A to Z we are assume something that is called variables. Constant means numbers, 1, 2, 3, 4 natural numbers, whole numbers are integers. Now an algebraic expression in which the variable involved have only non-negative integral power is called a polynomial. This polynomial is algebraic expression, one of the algebraic expression, but their power, their integral power must be non-negative, means must be positive. Example, x square 2x square plus x plus 3 plus ab. Now here in expression the power is 2, then positive 2, then this is called a polynomial. Here x power is 2, here 1, here 0, then here 1 1, then these all are comes under positive integral exponents, then we can say these expressions are polynomials. Suppose polynomial with one variable means only one variable, if you use to write the expression we call that is a polynomial with one variable, that is z square y square plus y plus 1. Here we are using only z, second expression we are using only y. These are called polynomials with one variables. Next, coefficient of the term. Coefficient of the term, that is each term of the polynomial consists, each term, every term consists, polynomial consists product of constant. Each term must be product of one constant. Each term must be product of constant. That constant we called coefficient of the term. Suppose 2x square, here 3 terms are there. Each term 2x square, 3x plus 4. Now here first term 2x square, second term minus 3x, third term 4. What is the coefficient of x square? It is multiplied by 2, the product of 2. Then we can say 2 is the coefficient of x square. Next, minus 3x. Here what is the coefficient? Minus 3, because here the symbol is minus, then we have to take coefficient as minus 3. Next, degree of the term. Degree of the term is sum of the exponents of its variable factors. Now variable means product of so many variables, means x into y into z, a, b, c, then these are called variable factors, means example x square y square z cube. This is one of the example for variable factors. Now a into b into c into d, e into f into g, these all are variable factors. Now degree of the term is sum of exponents, sum of powers of variable factor. Now here example x square y square z cube, here 3 variables are there. What are the 3 variables powers? 2, 2, 3. Then we have to add 2 to 3, you will get 7. 7 is the degree of that term. Means here each term, it may be product of variables or single variable. But when you will write the degree of the term, you have to add all the powers of variables. Now here example x square y square z cube, 2 plus 2 plus 3 is equal to 7. Next, degree of polynomial. Degree of polynomial is largest degree of its variable term. Suppose largest degree of its variable term, each polynomial having more than 3, 4, 5, how many terms it may be? It may be 2 or 3 or 4 or any number of terms it may be. But we have to take largest degree of variable term, that is called degree of the polynomial. Here one example, I took 3 terms. What are those? 3x square y square plus 3xy plus 7. Here what is the degree of first term? 2 plus 2, 4. Second term 3xy, 1 plus 1, 2. Degree of the 7, 0. Then why we have to write a constant, degree of constant always 0. For example 8. 8 we can write 8 into x to the power of 0, because something to the power of 0 anything to the power of 0 is equal to 8. Is equal to 8. Then what is the degree? 0. What is the degree? 0. Like that, every constant degree is 0. Now, degree of the polynomial, which is the largest number? 4, 2, 0 we got. In that, what is the largest? 4. Then we have to take degree of the polynomial 4. Next, types of polynomials according to degree. 0 degree we called constant polynomial. I explained already. Then 7 minus, for example. 1. Linear equation, x to the power x minus 12. Here power not there, then that is x means x to the power of 1. Then 1 degree means we will call linear equation. Next 2. Quadratic polynomial means if the degree is 2, we call that is a degree quadratic polynomial. Here x square plus x plus 7. Then what is the degree of x? 2. What is the degree of x? 1. What is the degree of 7? 0. Then what is the largest degree? 2. Then what is the degree of this equation, this polynomial? 2. Then we call that is a quadratic polynomial. Next 3. Cubic polynomial. Cubic polynomial means here each term powers 3, 2, 1, 0. What is the largest? 3. If the degree is 3, then we call that is a cubic polynomial. See, constant means x into x to the power of 0. 7 into x to the power of 0. We can write 7 as 7 into x to the power of 0, because something to the power of 0, anything to the power of 0 is equal to 1. 7 1 is 7. Then degree is 0. Then constant degree always 0. Now, types of polynomials according to terms. Now, before that we learn types of polynomials according to degree. Now, terms. How many terms are there? That as per terms we have to call that polynomial. See, suppose one term is there, what we call monomial. X square y square, one term x cube 4. Why 4 is a monomial? Because we can write 4 as 4 into x to the power of 0. Then that is comes under one term. Then every constant is a monomial. Two terms we call binomial, x plus y. Here 3 terms, trinomial, x plus x square plus y. Then more than 3 we call multinomial. Then x plus y plus z plus 4. Here one thing we have to observe, multinomial, every multinomial is a polynomial, but every polynomial is not a multinomial, because suppose one term is there, then we call that is a monomial, 2 terms binomial, 3 terms trinomial. Multinomial, when you will call more than 3 terms, we will call multinomial. Every multinomial is a polynomial, but polynomial is not a multinomial.